I wanted to share some basics of probability with you. I'm hoping that this is familiar, but if not, I think it'd be some things you can pick up easily on. If these are familiar to you, just make sure that you're keeping these things in mind moving forward when we're discussing probability. The first thing is that probabilities will always be written as a fraction, decimal, or a percent, and they'll always be between 0 and 1 or 0 and 100% if you're dealing with percentages. The probability of 0 means an event will never happen. This is it's a literal fact. If there something is a probability of 0, it is impossible. Okay, so the probability that I am living in Virginia right now is 0%. Because I'm not living in Virginia, I'm living in Pennsylvania. And it sounds ridiculous, but just, for emphasis. This is like an example for emphasis. The probability of 1 means an event is guaranteed to happen. And then there's kind of a spectrum in between. So the closer to 0 an event is, then the event is less likely to occur. And the closer to 1, the event is more likely to occur. And this is the thing that is a very valuable thing to remember, and it is a very small thing, but there are few students who can consistently remember this and use it when they need it. Possible events in a sample space always add up to 1. So if you are tossing a coin and it's heads and tails, then you have 50% probability of getting a tails, 50% probability of getting heads, and 50 plus 50 is 100%. And there's nothing else that exists on the coin that would happen. And I know some of you are thinking about what happens if a coin lands on its edge. Well, that's possible. It's possible, but we're not talking about that. Okay, so we're going to just be making this as cut and dry as possible in those ways. So there's 2 types of probabilities. We have classical probability, which is used for making inferences or predictions about larger sample space. That's what you guys are maybe most familiar with. This also says classical probability, and it's not supposed to say classical probability. It's supposed to say statistical probability on the right over here. Okay, so just pretend, because I'm not going to do this again. I have to do this in one take. So calculated from past events has no bearing on future events. This should say statistical, guys. Okay, so classical probability is known as theoretical probability, and statistical probability is known as empirical or experimental probability. The ratio refers to probabilities that are supposed to occur. We've mathematically calculated them as a prediction. And then statistical empirical probability it's like a result of after an experiment, or you simulated a bunch of trials and then you record the results. You calculate classical probability by dividing the number of outcomes in the event by the number of outcomes in the sample space. So basically, what do you want to happen divided by the number of things that could happen. And then for the statistical probability, we're dividing the number of things that already happened by the number of total trials that we did. Still a ratio, still a percent. And so, for example, if you're looking at classical probability, you should roll a 4 on a die once out of every 6 rolls, something like that. And then for statistical probability, then we're looking at like calculating the ratio after you do something 1,000 times, or you toss a coin and it comes up tails 3 times in a row, and that's not really supposed to happen mathematically, like for our predictions, but it does happen. So that's the difference quickly between classical and statistical probability, or theoretical and experimental probability, as you might be more familiar with.